Hello, so we're back, and this time we have an urgent job. Now, I'm not gonna lie, usually the computer shop this laptop is coming from is charging £80 for a motherboard repair, but because the customer wanted today, is £50 on top. So it's kind of important to fix it, yeah? And not only to fix it, but to fix it today. Now, that's a Microsoft Surface laptop, but the laptop came here like, I don't know, the back cover is coming out. So someone opened this laptop. I didn't open, so I don't know what is inside. Yeah. So that's the laptop inside. So we have the keyboard and we have the laptop. Now this has to be fixed today. Don't forget that, yeah? What this is doing, I have no idea. Just assuming is dead. Let me plug the charger because I have the original charger here. Okay, so plug in the charger. We plug the charger. Let's try to find the voltage on the motherboard. So I'm not sure where we should check the voltage. So check here, the charging port has a bunch of wires. I never fix something like that. We have light here. Check that. We have light. So does mean the laptop is charging? Where we can check the main power rail? Probably those capacitors, right? And we have nothing and nothing. Good. Power supplies. Those are power supplies, and we have nothing. And we have nothing. Okay. Where is the battery connected? Probably I can see the cable here, so probably it's going on the other side of the board. Not sure again. Here we have capacitors and we have nothing, and here we have nothing. So basically we have no voltage on this motherboard, which is strange because we have the light on the charger. What is this here? We have 15 volts here. So those are MOSFETs or what? Let's check together. Okay, so we can see the input circuit, right? So we have two MOSFETs. Check that. Here are together. So what do we have here? Here we have nothing. Okay. Here we have 14.5. And here we have 15 volts. 14.5. Okay, that's not right. And on the gate we have 14.4. 14.4 on the gate. Okay, that's weird. But the thing is, after this MOSFET, I have no voltage, and I don't know why. So what I will do, I will unplug the charger. Let's switch the... Actually, let's not switch. Let's check the voltage, because the battery is still connected. We have nothing, nothing, and nothing, no voltage. Let's switch the multimeter on the ohm range. So on the ohm range, here is fine, it's not short. The MOSFET, this one is not shorted, and this one is not shorted. Okay, this looks bad. The gates are fine. So basically we have no we don't have the right voltage on the gate of those MOSFETs. Yeah, I believe those are channel N MOSFETs. We should have 25 volts on the gate. Those capacitors, no one is shorted. So this is quite a strange fault. So probably this is the main power rail and it's good. It's nothing shorted here. No, nothing. Nothing. No. No. No, no shorted. So how we can repair this? Because I never fixed something like that. No, it's not short. So do we have some BQ chip here somewhere, or how this is working? Like a normal laptop? How we can fix something like that? You know what? I will say let's take the board out because I'm curious to see what is on the other side. So this is some kind of heatsink because you can see it's part of the big heatsink. I'm just curious to see if we can fix something like that. I'm curious to see the design. Okay, so the heatsink is coming out. This is something what you expect to see on an Apple laptop. Hey, it's a nice board. I don't know what is here behind of those things. Okay, so basically you have to open the hinge to take out the board, right? So it has to have probably some screw under one of those bits. What is that? Oh, this is a chip. This looks like a power supply chip. Hmm? This looks exactly like a power supply chip. Maybe we can spot something quickly. Okay, those are coils. I can't see anything wrong here. Oh lord, this is a big coil. And we have a normal chip. Let's check what we have on the coil. The coil is not shorted. No, everything is fine. Yeah, all good here. Let's see next. So here we have another power supply, right? No, this is the sound. No, this is the sound area. What do we have here? Here we have some power supplies. More power supplies. Let's see what we have here. Good. Good. Coil, good. Probably some screen inverter. And that's a fuse, right? Which is not good. Wait, this is an inverter. And this must be a fuse, or this one? This one is a fuse. But that one looks like a fuse. Strange. Strange. Okay, and those are the screen connectors. Yeah, it looks like. And here we have more chips. Good. Okay, so here we have more screen connectors. Touch screen connectors, right? Yeah. And we have a screw there. You can see the screw. So we took the motherboard out. Lol, check here the battery connector. That's what I call a proper battery connector. Let's see the voltage. The voltage on the battery is 0. Let's see, the battery is taking current. Kind of low current, minus, plus. And it's taking, check there, 1.6 amps. Let's rise to 3 amps. It is charging with 3 amps? Yeah, it is. So the battery has like how much? 7.5 is saying on the battery. But it's interesting because the battery was disconnected. So that means either it was dead or it was a short somewhere. So we push some current into the battery. Right? Let's check the voltage on the battery. 7 volts, still low, but should charge. Check that connector. That's a proper big connector. Let's see if it's charging. I mean, how can I know if it's charging or not? No, I don't think it's charging. But the main power is 7.9. Wait, so that means my laptop, it is working on the battery, but it's not charging. That's what it means, right? I mean, the main power rail from the battery is present. It's not present the one from the charger, but the one from the battery, it is present. We have 6.9. Okay, so how we can figure it out what is wrong here? Huh? What do we know? We know the voltage gets stuck here somewhere. So we know after those MOSFETs is no voltage, right? Yeah, here I have nothing, and I don't know why. Now my question is, this power rail is going, this is the main power rail? Let's see. This is the main power rail or not? It's not. So this is going to the charging port? My question is, this is going to the charging port? Yeah, okay. So the charging port is coming straight here. Okay, then we have two MOSFETs, and I'm pretty sure there has to be some current. Let's go with the charger. So we have like, what, like 15 volts? Yeah. low current, like we have, how much current we have, like 60 milliamps, 600 milliamps, sorry. Now let's see what is happening, yeah? So coming with current here and nothing happened. Yeah, here is ground. I mean, it's taking no current at all, nothing. Now the only way to figure it out what's going on here is to find where the output of that MOSFET is going. So in this way, we will know the power flow, yeah? So, okay, we know that we have two MOSFETs, yeah? I got it. But after the second MOSFET, where is going? Because it's not the main power rail there. It has to go somewhere. It's coming here to this chip. That makes sense. And the gate of this MOSFET is coming here. So you can see that's the gate of this MOSFET. Yeah, it's not the source, it's the gate. And it's coming straight to that chip. Okay, so if you have this board, have in mind this chip is managing the input MOSFETs, okay? And now we are focusing on this chip. This is like on a MacBook, the chip which is boosting the voltage, yeah? So this chip is creating the main power rail. Look at the coil, yeah? So let's pay attention and see what voltage do we have around this chip. Because we have 14.5, check on the screen. So basically we have voltage on this chip, but this chip is not doing the job. Can be the chip, can be. Let's see if we have input voltage on the MOSFETs. And we don't. And that's strange. No, we don't have voltage on the MOSFETs because the first two MOSFETs are managed by this one. Let's see online what we can find about this chip. Okay, 923. Okay, we found the datasheet of this chip. Yeah. So input voltage, system output voltage. Okay. Good. So this is the schematic. It's exactly like in the MacBook. This MOSFET, which is saying it's optional, is not. Actually, there are two MOSFETs. And we have a pin AC in, which probably this is AC detect. Yeah. Okay, I got it. No. Pay attention here. Yeah. How can I zoom this thingy? How can I zoom it? Yeah, from here. So check here. Those thingies, no, not this one. No, okay. No, no, no. Here are two MOSFETs. Yeah, yeah. I want to check this pin. You see, this is a divider. So AC in pin is where? AC in is pin number 19. Yeah. Let's see. So pin number 19. $16, $19 is here, and we have 1.3. We have 1.3 volts on the AC in. Let's see AC in. Pin voltage is greater than 0.8, so it's fine. Yeah. So that pin is fine. So why is not working? Probably because the chip is dead. I mean, we had this. 1 second. We had this. If I remember, let me find the schematic. Yeah, this is the schematic. You remember we had a HP laptop and the VDD pin was not 5 volts? And we have DC in, we should have voltage from the, we should have voltage. So DC in and VDD. DC in and VDD is next to the other. Lol, 17 and 18, let's check. So this one is DC in and it's dead. Yeah, dead. And VDD we have 0.5 and again it's not good. So why this pin, which is DC in? You know what is DC in? I will show you what is DC in. So DC in are two diodes, you see? So one is coming from the system, from the battery, and one is coming from the charger. In this way, this chip, it will always have power. So DC in voltage has to be, doesn't matter, 12 volts, yeah? So I'll come with the power supply, DC in. DC in, input of an internal LDO. Yes, yeah. So it's powering an internal LDO. Connect a diode from adapter and system outputs. Okay. So should work with any voltage, with any. So let's come with 14 volts there and see what is happening. It's taking 600 milliamps. Lol. Why is taking 600 milliamps and the voltage get dropped to 2 volts? Let me lower the voltage. 600 milliamps. Let's get a thermal camera quickly. So what is taking 600 milliamps is my fault with this board. That means it's burnt. So I said this resistor, right? Bro, I need a ground. There's no ground, right? No, it's no ground. It's no ground. It's no ground. I swear, those people are like Apple. they don't put ground on the holes. Check there what is getting hot. So DC in the chip is shorted. Yeah, it's dropping the voltage to 3 volts and it's taking like 600 milliamps. So the chip is dead. Now, not sure if I have this chip, but let me try and find it. Yeah, let me try and find this chip. Yeah, the problem is I don't have the chip, so I have to order the chip. So what can I say? So I'm gonna stop now, and we're gonna fix this next time, right? We found the problem. Yeah, we found the problem. Yeah, okay. I just realized, yeah. So basically, I said we found the problem. Yeah. So check here. If this voltage is missing, my diode is burned also. Yeah. So we have a double diode here, double Schottky diode. So the diodes are burnt, and also I need that double diode. Yeah. Okay. That's not a problem. Next time, yeah? Bye. Okay, so we are 2 days later and the parts arrive. Check here. Proper nice, the Mauser. They are, packaging proper nice way, everything. So every time I get the parts like that. Expensive, but nice. So this bag probably is only for one chip. Huh? All sealed. Oh, lol. It's like buying a ring, you know what I mean? Yeah, so that's our chip. Good. And I bought some diodes, and I bought like 3 diodes just to be sure I have in the future. Yeah. So those are the double diodes. They are cheap, the parts are cheap, are not expensive. But the postage is like a little bit over 10 pounds because they are sending the parts with FedEx. Okay, let's replace the chip and the double diode. So the notch is there. The notch doesn't have a mark, so we have to keep it in mind. Just a little bit of flux. So I believe this is our double diode. Not sure, but I'll check. Good, so we remove the old chip. Let's come with a new one. Hopefully it will get soldered. Yeah, it's fine. A little bit of flux. Okay, let's check about that double diode. So if I remember, this pin, right, has to go here. And it's not going. No. Check there. Check there. You see that resistor? You see it has a bump on it. So what is happening here? So probably the diode is going here. Yeah, and resistor blow up. And resistor has to go here. Yeah. Does mean my diode can be good? Let's check. Good. And good. Okay, so the double diode is good. I ordered the double diode for nothing. Now let's remove the resistor. It is important what resistor it is? No, really. So we remove the resistor. Let's have a look for another resistor. So what resistor do you think we should use? Huh? 100 ohms? It's a little bit too high, right? 100 ohms. Yeah. Let's see something else. 3 ohms. 3 ohms, it's about right. I mean, I'm not sure, but it's a power rail, you know what I mean? This resistor is meant to get burned in case the chip is getting shorted. And also, it's just limiting the current in a case of jumping voltage or jumping current, but actually jumping voltage. It will limit the current. I always told you, just because the manufacturer use a specific value of the resistor, that doesn't mean you have to do it. You understand? Manufacturer is seeing on is designing the schematic on a certain way, and you can redesign it on the way how you see it. Yeah, obviously it will do the same job. I mean, obviously it will work, but I'm curious to see if that was only the problem. So cooling down the board, let me grab the charger. Okay, so we have the charger, and I really want to see what's happening here. Plug in the charger. Let's see the voltage. That's the first thing what we have to check, the voltage. I just want to be sure the board is not coming on. So the voltage on the coil is nothing. Oh lord. Okay, the voltage on the resistor we replaced, yeah? 14.8, you can see on the screen. So we kind of fixed the problem, but still I have no voltage. Remember, here we should have our main power rail. So we have like 0.5, and I'm not happy with that. If I remember from the last time, we have to check the internal LDO. And the internal LDO, so let me see, on this pin we have 14.8. Internal LDO was, I think, here, and has to be like 5 volts, and it's like 1 volt, and that's not fine. Or here is 5 volts, lol. Okay, everything is fine then. We have 8.8 here. 1 second, maybe it is working. I mean, otherwise, you remember we didn't have any voltage, so we have 8.8. That means the voltage it is passing the... Wait, so the main power rail is actually 8.8? Huh? Let's check the main power rail. 8.8, the main power rail is present. You know what? I think we're done here. I think we should test the motherboard. So the main power rail is present. Exactly what we were looking for. Right? Yeah. We were looking for to get the main power rail present. And now it is. Now the hard part is to put all those things back. But, you know, I'm just trying to give you an idea about the approach on a case you are working for the first time on a motherboard. Yeah, I never fixed this kind of motherboard before. I know it's looking complicated, but remember what I told you. Most of the faults they are on the power rails, and that's what you have to focus. You know, just getting your main power rail present. I can't feel the CPU hot. And that's not a good sign, but it's Microsoft, so it can be different. Can be like when you press the power button, so the board is not coming on itself. So the CPU is cold. That means the laptop is not working. Now, I'm not sure where is the power button. Probably it's on the keyboard. Let me plug the keyboard. Yeah, the power on it is on the keyboard. And the keyboard has to be plugged where? Anyone can see where is the connector? Here? So pressing the power button. I can't believe we have picture. That's crazy. And the CPU? It's like it's like warm. You understand what kind of efficiency is here? So I have the CPU without heatsink, and it's like warm. Now it started getting hot. No. It started getting hot. Let me disconnect it. Yeah. I can't believe it's working. That's crazy. Lol. All good? Good. Let's test it one more time. Let me plug the charger. Let's plug the keyboard. You remember this laptop came without with the keyboard removed, so it's no problem to stick the keyboard back. Power button, the laptop it is coming on. Loading the windows. The fan is spinning. No, not yet. It's not even point. I mean, and the laptop is on. Huh? Yeah, the mouse pad is working. Everything is fine. Okay, good. Let me shut it down. It is charging the battery. Okay, good. So we'll stop now. Not sure what model is this. 17. One 1769. What surface is this? Hello, Microsoft Surface 1769. Come on, that can't be true, right? I can't believe on what I work. I can't believe. So actually I pay for the parts, exactly how much is a new motherboard. Oh, okay, it's faulty. So actually it's not that expensive. Lord. Lol, the whole laptop is like 200 pounds. 165 pounds. SSD faulty, 100 pounds. It was looking like a brand new laptop, like something very new. Well, okay. So one more time, I will point this. Yeah, it's no point setting the bar low. Yeah, just because you never work on a laptop. I mean, yeah, you can open. Maybe you can't fix it, but you are still left with the experience. So you understand? You are still getting something, even if you cannot ask for the money for the repair. Yeah, if you don't fix it, the experience it will, accumulate, and at some point it will be helpful. Okay, great, fantastic. Hopefully you enjoyed the video. If you are looking to support this channel, don't forget you have the YouTube membership and you have Patreon in the description. I will say thank you for watching. Like and subscribe if you like the video, and see you on the next one. Bye.